Hello everyone, today we're going to be proving the product rule. We've already proved it before by the f of x, g of x method. We're going to be proving it by a slightly different method, which I actually think is more elegant, so I'm going to put it up. So, we start with y is equal to f of g of x. So two functions, f and g. And then we're gonna look at our polynomial or whatever we have. So and we're going to take one point, and then we're going to take a point that's very close. So I'm going to call that a delta x. And so a small change in x will cause a small change in delta y. So I'm going to say that y plus delta y is equal to f plus delta f, g plus delta g. And the reason it's delta f and delta g is because a small change in x will be caused by a small change in f and g. So I'm just going to multiply out these brackets a little bit. So we're going to have y plus delta y. Something I learnt when I first did this problem is it's really important to write out both sides of the equation every single time, to not just go equals, 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 and because that means you don't actually see what's on the left side, which becomes important in a moment. So that's equal to f of g, or f of g plus f d delta g plus g delta f plus delta f delta g. Maybe I should do some different colours. I'm going to do some different colours. Right, so if we remember that y is equal to fg, then we can say that fg, I'm going to write that in red because that's the important bit for the next one, f of g plus delta y is equal to f of g plus f of delta g. Oh, we got blue now. That's very nice. G plus g delta f plus delta f delta g. Oh, lots of colours. We like colours. Well, we're going to cancel the red ones. So we're going to be left with delta y. So small change in y is equal to f delta g plus g delta f plus delta f delta g. Right, so the expression we're looking for is something in terms of delta y by delta, or rather, a better way of explaining this is, we know what dy by dx is, or at least if you've been following my channel, you know what dy by dx is. It's the derivative of the function of y in terms of x. And we're not too familiar with this delta notation. Delta just means a small change. And so what we're looking for is delta y by delta x, which is a small number, because we got a really small number here, but it's the limit as delta x tends to 0. So as delta x tends to 0, these two expressions become identical. As delta x tends to 0, these two expressions become identical. So what I'm going to do is I'm going to divide this whole expression by delta x. Okay? So we're going to get delta y delta x over delta x is equal to, I'm going to split these fractions up, so f of delta g by delta x plus g of delta f by delta x plus delta f delta g by delta x. So I've written it in this way with the delta something over delta x, just so that when I apply my limit, everything is a bit simpler. So I'm going to apply the limit as delta x tends to 0. So this here, the expression at the front will become dy by dx, which is what we were looking for, not a delta. I keep drawing a delta. Oh dear, it's actually really... Ah! All right, here we go. Yes, we made it. Okay, dy by dx will be equal to f. This will just become dg by dx plus g, and this will become just df by dx. And then this bit here is key. So what we have originally is a small number times a small number. So small number delta f times small number delta g over small number delta x. What we have when delta x tends to 0 is... Alright, I'm going to rewrite that. So is regular size number times really small number, because delta f and delta g will tend to 0 when delta x tends to 0. So we've got a normal number times a really small number, and that's just going to be naught. So what we're left with is our expression here, which is the product rule, which is what we're trying to find. And I think that's really neat. I hadn't seen this proof before, and I thought it was far more elegant than the method I had done before, because you had to see something out of nothing, and I feel this one's a bit more intuitive. So I hope you like it. Thank you for attending this video, and I'll see you all next time.